The broadcast is now starting. All attendees are in listen-only mode.
Well, good afternoon, everyone. My name is Bill Brayton, ATRA Senior Research Technician, and welcome to the Part 2 internal series. But first, let's take care of some business. Today's presentation is sponsored by TransTech. We have a video here for you. Now, these are the good folks at TransTech that make this possible for you guys to sit down and enjoy lunch with us.
They've been reliable, they've been dependable over the years. If there is a problem or anything like that, that is close to OEMs that we've seen. It's a good product.
When I was being taught to rebuild automatic transmissions years ago, we were not allowed to use any other kits other than a TransTech kit.
Just in their research and development, and they do in the different lip seals and the type of material that they use is far better than other brands.
There really is no comparison. Instruction inserts on the bench, properly cut, fitting, sealed. When it comes time to assemble the transmission, every gasket is sealed, that's possible.
But we've been using them since I started in the business, and we have no problems.
I use TransTech kits because we need our transmissions to work properly for thousands of miles long after the warranties run out.
Since Freudenberg come on board with Corteco, it's been like DNA, because right from the start, if there was a problem, you could call and you could talk to someone and they would take care of the problem for you.
All right. Next up, we have the rest of the year in dates for the webinar training or webinar lunchtime series, so you can get your sandwich going and get some training at the same time. So we appreciate you folks for coming out, and we look forward to seeing you folks in the future. It's never too early to write in October 27th through the 30th on your calendar for this year's ATRA Powertrain Expo 2016. This year we're going to be in Paris. That's Paris, Las Vegas, a new venue for us, a larger showroom floor, really great. So make sure you make plans to be there. Any questions or comments today that you might have, feel free to email us at webinars@atra.com. And if you have any questions during the webinar, feel free to write them in the box, and we'll get those questions answered straight away. Let's see here. When you registered, you should have your Adobe or PDF file for today's presentation. If you don't, let us know. We'll make sure you get that. Also, I have a 2-page PDF edition in the handout section. You guys can download that PDF. Those are torque specifications that I put in the last minute. So that's available for you guys as well. All right, we're going to start today off with a quick review. Because I feel they're important. The computer unbolts from the 6T40. That's one of the major differences, and major differences between the 6T and the 6F35N is the computer is bolted to the valve body on the version, it has an external computer. Once again, our pry points, when we get it to that point, we want to be careful not to damage the gasket sealing area, very smooth area. We don't want to use any chisels or wedges to create a potential leak. So we use those pry points illustrated to get the cover, the bell housing, off of the main case. Also, as part of our inspection, with this bushing inside the stator is very critical because they're on the shaft. So the bushing is the seal for the TCC circuit. And if this is worn out, you may get TCC code, so it's very critical to inspect this bushing. And I like to do it a very simple way. We're going to use an 1/8" wide piece of cellophane, probably 75 thousandths thick, and put it on the input shaft. Now we're going to slide the stator over the shaft, and the stator will stop. If the bushing is good, you can't push the stator over the bushing with the tape on it. If it does go past the tape without hurting the tape, that is a worn out bushing and it must be replaced. Very simple way to inspect it, and efficient. Okay, once again for review, we've got all our guts to take it out as individual pieces. We can grab the input shaft and up and out it comes, the whole back half of the transmission. The Ford version is much more difficult to pull out of this rebuild book right now, and the center support for some reason is a little bit tighter than the GM version. I was unable to pull this out in the Ford version, but in the 6T40 it comes up and out of here nice and easy. We're going to show you how to install it. This is part one was about taking it apart, and part two is about, also we went over the use of the factory tools for the drum support down in the bottom of the case. There's two different methods here. We've got the factory tool, which I found on eBay for 120 bucks, and the alternative is to use a small engine. Either way, a special tool has to be used because these solid rings that need to be used get distorted severely when we put them on, whether you use the factory tool or a 90-degree pick to get these sealing rings in the groove. So we really need a sizing tool in the small engine. So now let's put this unit back together again. We reviewed it, and we reviewed some of the stuff from part one. So let's start putting it back together again. We're going to start by installing a new 2.6 piston. These are all molded pistons, and they should be replaced on each and every rebuild. 2.6 piston orientation is that there is a bleed hole that must go at 12 o'clock with the orientated where the worm casting is on the right and the casting for the differentials on the left. So top of the transmission when we're installing it down into the case. Okay, we've got our tower with its formed sealing rings down, whoops, on the left. The bottom bearing goes in curved side down, flat side up. The curved side fits on the right. We covered the 3.5 reverse 4.5/6 drum in part one. Okay, so We've got our top bearing on, the flat side goes down against the hub, and now we're going to put the sun shell, because it's easier to do it on the bench right now and put it down in the case of the unit than to put the drum down onto the support and try and put that sun shell on there. It's just much easier, I found, to put this on in the bench in a piece, such as illustrated here. Let's see. So now we're going to go with the 2/6 clutch pack down onto the sun shell. Pretty straightforward, except for you want to make sure that you have clearance. We're really not concerned, as we go through the unit and the stack up, you'll see that we're really not concerned with the exact measurements. There hasn't been, GM has been famous for not publishing clutch clearances. You can look in most all missions, and that's one thing you will not find is clutch clearances. And what we're looking for here is the friction in between, friction in the case between the two arrows here. There's a step down. Here I measured it with a calipers and thousandths here from the clutch face to the step in the case. This is where the low and reverse clutches, low and reverse sprag is going to sit in the case, and that's going to be our clutch clearance. And the thing about clutch clearance is that it's really not that critical anymore. Type of unit has one of the clutch clearances, I think 10 thousandths minimum to 90 thousandths maximum. So there's a huge spread, and clutch clearance isn't as critical as it used to be, because it's controlled the rate of apply and the rate of release now, and based on the input from the input and output speed sensors to the controller. So clutch clearances aren't what they used to be. We just need to make sure that it's there. And the factory book says if there's area, you either replace the clutch pack or you've incorrectly stacked the clutches up. Next, we're going to load the L&R one-way clutch down into the case. This will fit on that step above the 2/6 clutches. And one thing to note about this low and reverse one is in a permanently assembled unit, so you're going to have to clean it as best you can. This is another major difference between the 6F and the 6T series. The 6F35 completely comes apart, whereas this is a permanently sealed one. Now, before we go any further to load the clutches up, we're going to stack them up onto the center support. And with the cushion plate next to the piston, and the pressure plate will be going against the low and reverse. See between the two red here, we measured it there again. This is just to make sure that we have clearance here. We've got 58 thousandths clearance here, which is perfect. If you set this up in the center support and there's no clearance here, you've got it stacked wrong to be replaced. So now we can stack our clutches down in, pressure plate first, then the frictions and steels. And what I've done here, I got a little frustrated when I was putting this back together for this presentation, because I couldn't get the orient tabs correct in the case. So once I finally twisted it around 4 or 5 times and got it to land where it was supposed to, I took it off, and this is my recommendation to you guys so you don't fiddle around with it so much, is to, when we're disassembling, you take it right over to the grinder coming through the case, walked it over to the grinder and made a grind mark. Now, when I go back together, I know where the tabs go. I can put the clutch back together and drop the cushion plate right in there and save a mess of time and frustration without fiddling around on where the tabs go. And I'll get on that. Okay, now we're going to load the planets in. We've got the LNR planet, which it's the reaction carrier. The proper name is the reaction carrier. You can see on the right how it splines into the LNR spragtures. The outer washer is for the planet to planet. The inner washer, the inner thrust bearing, I should say, is for the sun gear. Now here's our sun gear going on to our reaction planet, and you'll see there is an identification manual wants the groove to face up. The teeth, the identifying marks in the teeth will be down or closer to the planet. I measured the depth. I measured the depth of the step on the sun gear right here. And it's the factory manual wants the groove to face up. Okay, now we're going to set the input carrier down into the trans. We want to make sure we've got the large thrust washer in place. It's down in the planet. And on the right, the top has the skirt that faces up. The skirt faces up. That's just a critical area right there. It's a little bit different shape of a bearing than we're used to. The skirt faces up. And then lastly, for our gear train is the output carrier going down into the planets and that of the planetary gear sets into the unit. So next we're going to go with our center support down into the unit, but prior to doing that, we want to stack up our 1, 2, 3, 4 clutch clearances. And there again, this is just to make sure it's correct prior to final assembly. Here I measured this out to about 40 thousandths. There again, it's not super critical. They just want to make sure that it does have clutch clearance. Okay, notice the long legs go down on the piston housing. It goes down. We line it up with the feed holes facing the valve body casting. The worm tracks in the case should just seat very nicely down into the case. Now we're ready to install our 1, 2, 3. Prior to doing that, and I failed to put this in your handout, and this is a note for you guys to write down. Install the output sun gear before the 1, 2, 3, 4 clutch pack. You see that in red on your screen. I want you to take a minute and make a note of that. Write that down. Give you a second to do that before I keep going. The reason why we're putting the sun gear in prior to the clutches is you'll have to get those clutches lined up to drop that sun gear down in through those clutches. I got so frustrated, I took it back apart, put the sun gear in, threw the clutches down on it, boom, was done in 5 seconds. And I sat there and got frustrated trying to put the sun gear in, and I just wasn't happening. So the way to do this is you put the sun gear in first, and then you load the clutches up on top of the sun gear. Here again, I use the grind method, the grind mark method, to put the cushion plate in for the 1, 2, 3, 4 pack. And here's the perfect illustration over here in the lower right-hand corner of the lower left-hand, I'm sorry, in the lower right-hand corner of the picture. You could see the tabs. It looks like the tabs should go where there's 2 slots, but that's not the case here. Only 1 tab fits in a slot. That's why we grind the mark. We're able to a bunch of time not messing with where the tabs go. This lines up towards the valve body casting as the other one did. And then we can drop our clutch pack down onto the output sun gear shell quite simply, and quite simple and quite quick of a job. Okay, now in with the big beveled snap ring here. Flat side goes towards the plate. And once we get the snap ring in the case, in the groove, we're going to take a screwdriver and a light hammer and tap it to seat it back in around the snap ring. Oh, I mentioned that the factory manual states the opening of the snap ring must be installed towards the bottom of the case at the 6 o'clock area. I haven't spoken to a designer engineer why that, so with putting the snap ring in and out of the case, couldn't really see why they wanted the snap ring down at the bottom of the case. But if the factory manual states that's where they want it, then that's where I'm going to put it. Before we put the output gear on, we must here the final thrust bearing, the park assembly, the park pawl, return spring, and shaft, and then finally our baffle. Now we're ready for our output drive gear. We've got a plastic fiber washer that goes on top of the gear and a thrust bearing that goes down into the pocket. The curved part of the bearing goes down, the flat side faces up. It fits nicely down to that. Also, we have a new seal where our chain snubber / reservoir is going to live. This will feed the lubrication circuit while the vehicle is being towed. We've got that all assembled. We're going to go with bearing here that sits down on the case prior to installing the driven gear and chain. The chain has enough slack in it prior to final assembly that we can put the driven gear and the chain all on as an assembly. We don't need to lift this because that output gear is pretty stout. Make the whole assembly very awkward and very difficult to remove as a set. But in this case, it assembles independently of the gear and the chain, and we can put the gear and the chain on in another step. Now our differential sun gear and bearing and a thrust bearing that rides up inside the differential, and we have a large thrust bearing that we can install now onto the differential housing, ready for case gaskets and case seals, and then the bell housing. Let's see, we've got our gaskets on, we've got our new seals on over here on the right. We've got another seal for our snubber / reservoir side. We've got our pump, our complete pump assembly installed into the bell housing. Now these are also, you're going to see here in a minute, a two-stage torque sequence. These are also a two-stage torque to yield bolts in some of the cases that we've started to see where they come with aluminum bolts. I don't quite understand that, but that's just what the engineers wanted to do, because these are steel bolts. These are not torque to yield bolts, as is the case as well. And they have a similar torque to yield type final torquing sequence. The torque sequence of the bolt is a star pattern, as recommended by the factory. Go to the lower left, to the upper left, to the lower right, and then back through that as we bounce through the case. So in a star pattern the first time around. And this is another interesting point, is the torque is only 89 inch-pounds, amount of torque I think I've ever seen a bell housing bolted to a case. And as I said, it's a two-step process. You go once around at 89 inch-pounds, and then you get on to the bolts one more time, and without looking at the torque, you go for another 50 each bolt, and that's the final step for bolting the case, bell housing to the case. It's pretty unique. Okay, here in part 2, we're covering the valve body breakdown. We've got 5 take up the pulses in the PWM solenoids. We have a bonded plate over on the right. The case gaskets, the separator plate gaskets do come with the new kit. We just have to get the old gasket off without wiping out the plate. We have 6 check balls for this unit and their locations. And here's the valve body breakdown with names and descriptions. And when we're working on these valve bodies, folks, the most important valve in this whole thing is number 2. And they should all be inspected. Every valve out of every bore, out of every time. The life you save could be your own. But the most important valve in this whole thing is this actuator feed limit valve. You might recognize this on, in regards to the 6F35N. They call that the same valve, same place. They call it the solenoid regulator valve. More of what it does. The actuator feed limit valve in the Chevy does the same thing as it does in the Ford, and that is feed the solenoids a proper amount of regulated. It's worn out. The oil won't be. You'll have soft shifts, delayed engagements. I've seen violent in and out of gear, all kinds of crazy problems. So this valve becomes very, very critical. This is for this valve, boring tools and whatnot, oversized valves. So it's very critical to be aware of that. Prior to the show, I looked it up in Mitchell, and I believe these are running about $200 complete from the dealer. Not a bad deal into that as an option. But always, always, always take this valve out and inspect it. You only have one port here where you can vacuum check it if you're using that method. Better to get a flashlight down that hole or get a bore gauge down out of the wear here, because that is very, very critical. You might even make a note if you've got a printed out handout that this is the standout valve number 2 over here that you want to pay attention to. Not saying that the other valves aren't important, but this is one of the most critical right here and most prone to wear. Vacation table and spring chart. The spring measurements are these measurements are not factory specs. These are the measurements that I measured these springs that you saw on the previous page. Those numbers are for your, or if we have a broken spring, we can go to our spring box and use these dimensions to get something that's going to be relatively close to what we were using. Unlike its bigger brother, the 6T70, we can take the solenoid body apart, check them by removing these small number 10 Torx bolts. I would highly recommend that when you're going back to just use your small speed handle or a nut driver handle to put these small screws in, because they're in some pretty soft plastic, and any kind of guns, ask me how I know that, because I did it, so don't do that. And we can take the Tecum away from the solenoid body and take the solenoids out of the plastic body itself for cleaning. Steel retainers on the top of this picture, these are all the same. Pretty simple, they just come right out. Now we can pull these solenoids, the individual solenoids, out for cleaning. One note I want you to make, I found this earlier this morning, that I missed. I did not correctly identify a solenoid number, so I'm going to ask you to please make a change in your handout. The 2.6 solenoid is solenoid number 4, and the 1, 2, 3, 4 solenoid is number 5. So you have different names for them. Now, one thing I want you to note here is the line pressure control solenoid, solenoid number 2 and solenoid number 3 are normally open solenoids. The yellow 4, 5, and TCC are normally closed solenoids. The other day I had a guy call me in, and he had that was a solenoid stuck off closed code. And I said, well, here's what I want you to do. I want you to change the yellow with the yellow, change solenoid number 4 and change solenoid number 5, and see if the code stays with solenoid, and if it follows it or it stays at where PC5 was. You follow what I'm saying? So that way we can diagnose that, say, okay, well, the code followed the solenoid, so the solenoid's bad. Well, the individual solenoids are not available yet. With a free solenoid body in TCM. So this is a way that we can test it for sure, that that's what's wrong with it, and we can go to the boss and say, hey boss, I did this. This is a solid check. It needs a TCM. We can spend our hard-earned money for the TCM. The problem, that way we know we're solid on replacing a computer for a code like that. Okay, so we have our valve body back together. Now we're going to install the rest of the pieces here. We've got the output speed sensor, The inputs here again, the input speed sensor, another major difference between the 6F and the 6T. This wiring loom passes through and bolts onto the back of the case, where the input speed on the 6F is all internal. I got a part number for the plate. Kit doesn't match the plate. Local is next to your local dealer, and costs about $10. So that's just available. That's just available. Netflix pieces in. Be sure not miss the piston housing seals. That'll create shifting errors if you're shifting issues if you forget that. So here we got our valve body back on. We want to put the D10 on. And one thing I want you to is it has to be indexed into the MLP right where the roller's at. Right where the roller's at. This switch can be pushed to the left, and the roller can be installed. Experience that you'll get a no reverse. You'll get a no reverse or delayed engagements when that happens. Because somebody gets in a hurry, they're not looking, they push this down in here, they bolt it down, the switches all the way over to the left, things start, MLP starts then reading incorrectly, and you get engagement problems. Cover and engage loosen up the D10 and engage it correctly. So now we've got our valve body on. We've got a couple of plastic bits that need to go on. This was just merely a support ring on the right. On the left is our AT level control valve, and part one at length about this part and how we need to check the fluid at the correct temperature, because there is a flapper valve that opens and closes down here. They call this whole piece a control valve. When this closes, it forces it fills up. The fluid no longer runs through straight down and through. It closes, and now the fluid level comes of the control valve. So when this closes, this whole side cover is full of oil, and the solenoids are now operating in an ATF bath. Keeps them cool. So very critical. Okay, and lastly, prior to that, we're over on the right here. We're going to use a new solenoid filter plate. This is one of the major identifiers of the TCM and the filter plate. This is a Gen 2 TCM and filter plate. The Gen across the earlier models. So once we get that replaced, we can put the TCM on, tighten it down to specs, plug our sensors in, and put the side cover on, and we're good to go. Now we can turn it over to the R&R. This is what's in your handout. You should be able to pull that off of the handout and download this PDF and put it together with your handout material. There's a couple pages of torque specs, and here I want to illustrate, point out pump bolt to converter housing. Here we have it 89 inch-pounds, and then the second pass with another 45 degrees, kind of like the the torque to yield bolts, but these are steel bolts. So this is the proper assembly. Same thing goes down here at the bottom, the bell housing to the main case, 89 inch-pounds, first pass, 50 degrees on the second pass. All right, all right. Thank you. Thank you for attending today's presentation. If you hadn't had one of these units, a ton of these units out there, they're going to be coming out of warranty and they're going to be ending up in your shop real soon. So I appreciate your attendance today, and I think one more time I'd like to thank Transtech. If you have any questions or comments, now would be the time to put them in the questions box while our final video for the day.
When I use a Transtech kit to rebuild our transmissions, they're not just rebuilt. Those transmissions.
Okay, I see we have no questions, so in closing, you guys are special because you're looking out for your own interest in getting educated, and I appreciate you for that. My name is Bill Brayton. Have a great day. Thank you.